Continuing with section 8.2, we now turn to example 3 for an application of fitting a curve to a collection of points. Find the equation y equals ax squared plus bx plus c of the parabola that passes through the points 1, 3, 2, 2, and 3, negative 3. You can see the 3 points plotted on the graph below, along with the parabola passing through those points. We want to try to determine its equation. The equation of the parabola involves 3 unknowns, a, b, and c, the coefficients of the quadratic function that generates the parabola. So what we need to do is determine 3 unknowns. If we can set up 3 equations in those 3 unknowns, we should be able to solve a system of equations, which will turn out to be a system of linear equations in 3 variables to determine a, b, and c. That's going to be the method. Now, if a given point lies on a parabola, it means that for that given pair x and y, the equation should be satisfied. So if we take the point 1, 3, and we know that it lies on the parabola, then it also satisfies the equation y equals ax squared plus bx plus c. In other words, when x is 1, y is 3. That would give us the equation y is 3 equals a, x is 1, square it, plus b, x is 1 again, plus c. Okay, we'll simplify that in a moment, but let's turn to the next point, 2, 2. If that point lies on the parabola, then it must also satisfy the equation of the parabola. That is, when y is 2, x is 2. So replace y with 2 and replace x with 2. Then the third point is 3, negative 3. If that point satisfies the equation, then when y is negative 3, x should be positive 3. We get a times 3 squared plus b times 3 plus c. Well, what we've basically obtained is a system of 3 equations in the 3 unknowns a, b, and c. So here, the unknowns are not called x, y, and z. They'd be called a, b, and c. But it's just really a matter of labeling. It should still be the same type of linear system that we have solved previously. That will be more obvious if we simplify each of these equations. So the first equation, let's put the left-hand side on the right and the right-hand side on the left, so to speak. And the left-hand side, the a times 1 squared plus b times 1 plus c, could be written a plus b plus c equals 3. For the second equation, we could write, notice you have, so we've done this equation. Now this equation, 2 equals 4a plus 2b plus c. So let me write 4a plus 2b plus c equals 2. And then for the third equation, we can write 3 squared is 9, 9a plus 3b plus c equals negative 3. So now we're going to work with this collection of 3 equations, 3 linear equations in the 3 unknowns a, b, and c. Now, because we're anticipating that this system has just one solution, I'm going to go ahead and eliminate c from a couple of pairings of the equations because the coefficients of c are all 1, and it will just be easier to eliminate that variable than perhaps a or b. But you can choose to eliminate any one of the 3 variables as your starting point. So let's label these as equation 1, equation 2, and equation 3. Let's multiply equation 1 by -1 and write it as -a minus b minus c equals -3. And let's pair that with equation 2, and we won't change it at all. 4a plus 2b plus c equals 2. Now remember, what we're trying to do here is eliminate the c terms. That's what I decided to eliminate, and adding, that's exactly what will happen. Minus a plus 4a is 3a, minus b plus 2b is plus 1b. The c's cancel, and on the right hand side we would obtain -1. So that gives us one equation in two variables. Now we need to take a different pair of equations and eliminate c again. So let's pair perhaps equation 1 and equation 3. Again, I'll just multiply equation 1 by -1. That will be exactly the same as what we wrote previously. And then I'll just pair that with equation 3. That'll give me 9a plus 3b plus c equals -3. Okay, adding, minus a plus 9a is 8a, minus b plus 3b is plus 2b. The c terms cancel, as they should, and -3 plus -3 is -6. Now, I can simplify that a little bit because every term has a factor of 2. So if I divide that out, it gives me 4a plus b equals -3. So now, taking this second equation in the variables a and b, I'll pair it with the first equation above, 3a plus b equals -1. And let's now eliminate the b term. Let's call, what's the best way to label this? Let's call this Roman numeral 1 and this Roman numeral 2. So let's take equation Roman numeral 1 and multiply it by -1. I'm not giving myself enough space here, but I'll just put it below here. So what that would give me is minus 3a minus b equals +1. And then I'll just take Roman numeral 2 and leave it alone. 4a plus b equals -3. Okay, now I'll add those. The whole point here was just to cancel the b terms out. That was the easiest way to deal with this. So I just multiplied equation Roman numeral 1 by -1 and added it to equation Roman numeral 2. Okay, and then adding the terms -3a plus 4a is 1a. The b terms cancel, and 1 plus -3 is -2, and now I know my a, the value of a is -2. Okay, now going back to, let's use equation Roman numeral 1 in its original form. So going back to that, we have 3a plus b equals -1. Let's replace a now with -2 from the previous step and solve for b. So that's -6 plus b equals -1. Adding 6 to both sides, we obtain b equals 5. And then we're left to still determine the value of c. if we go back up to equation 1, that is this equation here, a plus b plus c equals 3. And now I can replace a with -2, b with 5. That is -2 plus 5 plus c equals 3, or 3 plus c equals 3. It would follow that c must be equal to 0. So I've obtained a equals -2, b equals 5, c equals 0. Now, the equation of the parabola is what I was trying to determine. The general form of that equation is y equals ax squared plus bx plus c. But now we know a, b, and c for this particular collection of 3 points. The points 1, 3, 2, 2, and 3, -3 given in the problem. And from solving a system of equations, we've determined those values to be -2, 5, and 0. So our equation is y equals -2x squared plus 5x plus 0, or more simply, y equals -2x squared plus 5x. So the equation of our parabola is this final equation here. And this needs to be what you write down as your answer. It needs to be the equation of the parabola with a, b, and c known values. And we can check this against the original graph. Notice the parabola opens down, and this quadratic function has a negative leading coefficient, -2. So whenever we see that, we know that the parabola would indeed open down. We could also find its vertex. There's the vertex formula, x equals -b over 2a. Or you could also determine that the x-intercepts are 0 and 2 1/2. If you find x-intercepts, you set y to 0 and solve for x. If you factor x from both terms, you get -2x plus 5. So one solution would be x equals 0, and then setting -2x plus 5 equals 0, we would obtain x equals 5/2 or 2 1/2. So this would just help us to verify that the equation that we've obtained, y equals -2x squared plus 5x, is the parabola that's shown in the graph in your notes. So just an application of using a system of equations to find the equation of a curve that fits a particular collection of points. That concludes the notes for section 8.2.